The paper presents a novel framework for the study and design of AI-assisted musical devices, categorized into 6 main categories: musical instruments, music processors, music generators, music recommenders, feedback systems, and educational devices. It introduces scenarios and personas using Nielsen's user-centered approach to illustrate design ideas, emphasizing the importance of user sentiments in the design process. The authors propose a taxonomy that is complete, easy to apply, and useful, providing a classification system for aims. They highlight the potential of AI technology in enhancing user experience and accessibility for musicians with disabilities, showcasing various scenarios where AI can be integrated into different aspects of music. The paper concludes by emphasizing the importance of understanding user needs and the role of AI in creating innovative solutions. In the realm of music generation, various scenarios are presented to demonstrate the potential of AI-assisted musical instruments. These scenarios include the on-hold scenario, singing elevator scenario, watch scenario, let there be light scenario, teach and play scenario again, and the Magi flute scenario. These scenarios showcase the use of AI-based music generators to create personalized music experiences tailored to specific contexts, such as waiting times, elevator characteristics, and user emotions. The Magi flute scenario introduces an accessible digital musical instrument, ADMI, that uses sensors for wind and touch pressure to control a synthesizer through an embedded deep learning system. This device assists users with learning disabilities, demonstrating the potential of AI-assisted instruments for inclusive music education. A generic architecture for designing musical devices is proposed, consisting of 5 layers: user stimuli capture and processing, embedded learning, music adaptation, music production, and user feedback. This architecture is illustrated in Figure 4. The implementation of Thera-Iman, an AI-assisted variation of the theremin instrument, is presented as a case study. Thera-Iman uses open theremin antennas and a camera to capture hand gestures, which are processed using a Raspberry Pi board and a teachable machine accelerated with a Coral Edge TPU accelerator. The system classifies gestures into trained classes, and the sound production layer is implemented using Sonic Pi and Open Sound Control (OSC) protocol. The Thera-Iman system produces audio as a function of hand positions and gestures, captured by the antennas and camera, and recognized by the teachable machine. This implementation demonstrates the suitability of the proposed generic architecture and the usefulness of the framework presented, showcasing the potential of AI-assisted musical instruments for individuals with disabilities. The FAIME framework is a comprehensive approach for designing AI-assisted musical devices, comprising a stimuli layer, stimuli adaptation layer, learning layer, and production layer. The watch, for instance, uses wearable sensors as a stimuli layer, preprocesses them, estimates the user's emotional state, and selects music for output. The paper presents a wide range of devices, including accessible instruments for disabled musicians and alarm clocks for people with sleeping disorders. A detailed implementation of the Thera-Iman, a variation of the theremin, is also discussed, allowing real-time timbre and effect selection through hand gestures. Future work involves evaluating the user experience of Thera-Iman with musicians and exploring modifications for performers with disabilities. The paper cites various references related to AI-assisted musical devices, emphasizing user experience and effective state assistant systems. It concludes with a list of abbreviations and references.